we'll start our session. So which of the following BJT configuration has highest power gain? Okay, so if we talk about our BJT configuration, so there are three type of BJT configurations are there. Okay, first one is what? Common emitter configuration, then common base configuration, then common collector configuration. Okay, so if we talk about our power gain in all configuration, first we'll go through power gain. So in power gain for common emitter is what is always very high. Okay, it is very high. For common base it is very small, and for common collector it is medium. Okay, so this is about power gain in the configurations. Okay, now for if they ask about current gain, okay, current gain. So current gain, if they will ask about current gain in common emitter, then it is what? It is medium. It is medium in common emitter. In base it is unity, and in common collector it is high. Okay, this is about current gain. Okay, this is about current gain. Then voltage gain. If they ask about voltage gain, then voltage gain for common emitter, in common emitter voltage gain is medium, and for common base it is very small, and common collector is unity. Okay, so like that you need to remember this table, because they will ask question from anything, either power gain or current gain or voltage gain. So you have to know about all configuration, this power gain, current gain and voltage gain. Okay, so here in the question they asked about high power gain, in which configuration very high power gain is there. So common emitter only power gain is very high, so option B is the right answer. Okay, we'll see next. The average DC voltage of a half wave rectifier circuit is what of the value of the peak input voltage? Okay, so if we see the average voltage, average DC voltage for half wave rectifier, so how we are calculating average voltage? So it is what? It is Vm by 2 pi. It is what? Vm by 2 pi, or equal to 0.318 Vm. Okay, like that you have to remember. It is like formula is Vm by 2 pi, and this is equal to what? 0.318 Vm, or in the percentage it is 31.8%. Okay, this is about half wave rectifier. Suppose if they will ask in full wave rectifier, so for full wave rectifier average voltage is what? Average voltage is what? It is nothing but twice of Vm by 2 pi. Okay, so this is equal to what? Twice of 0.3, this is 0.318, that is equal to what? That is equal to 0.636 Vm. Okay, or in the percentage you can write 63.6%. so like this you have to remember about half wave rectifier also or full wave rectifier also. Here in the question they asked average voltage, DC voltage for half wave rectifier, so it is option B, 31.8% is the answer. Okay, like that you have to remember everything. Now the 6 volt Zener diode shown in the figure has 0 Zener resistance. Okay, 0 Zener resistance and knee current of 5 milliampere. The minimum value of R, so that the voltage across it does not fall below 6 volt. Okay, so in this circuit what we need to find? We have to find this resistance, minimum value of this resistance. Okay, So how we will calculate, what is the approach, how we will go through that? So see, this is what, this is load current, and this is what, this is general current here, IZ, and one current is coming from here, you can see like it's a source current. Okay, so if we find IL, means if we know load current, then easily we can find resistance value, because this is what, this is 6 volt, so here it is 6 volt, it is in parallel, so across this R also the voltage will be 6 volt only. Okay, so how we will go through that? We can do KCL. Like KCL is what, total incoming current equal to total outgoing current. So here IS is incoming and IZ and IL are outgoing. So IS equal to what? IS equal to, we can write IZ plus IL. Okay, and we know IZ value, knee current we have, IZ equal to how much? 5. IZ equal to 5. IZ equal to 5 milliampere. Okay, it is given in question 5 milliampere, but we don't know IS value and IL value. So first we will calculate IS. Okay, IS we can find here. IS is how much? IS we can write this 10 volt minus this 6 volt. Volt is potential difference, 10 volt minus 6 volt divided by resistance is how much? It is 50 ohm. So this is equal to how much? This is 4 by 50, or you can write 80 milliampere. Okay, so IS is what? IS is 80 milliampere. Okay, like that. Now we know IS value. Now we know IS value. So if we put in this formula, IS equal to IZ plus IL, means KCL. So here we have to find what? We have to find IL. So IL equal to, we can write IS minus IZ. So IS is what? IS is how much? Sorry. IS is what? IS equal to 80 milliampere minus IZ is how much? Knee current is 5 milliampere. So this is equal to what? This is equal to 75 milliampere. Okay, now we know the IL value also. Now we have to find what? We need to find R value. So we know volt, we know 6 volt, and IL we know how much? IL is 75 milliampere. Now we need to find what? R value. So if we apply what? Ohm's law, V equal to IR. Okay, V equal to IR. So R equal to what? V by IL. Okay, so V is how much? V is 6 volt. IL is how much? 75 milliampere. So 75 into 10 to the power minus 3, like that we can write. Now we need to do calculation. So 6 divided by 75, and we can write like this. 10 to the power minus 3 means we can write 1000, like 100 into 10, like that also we can write 1000. So this is easy for calculation. This will be 3 times, this will be in 4 times, this will be in 2 times. Okay, so 2 into 4, this is what? 80 ohm is the answer. Option B is the right answer. Okay, so like that you need to calculate. Now the next question is, how many 3 into 8 line decoder with an enabler input are needed to construct 6 into 64 line decoder without using any logic gate? Okay, so encoder, this is decoder. Okay, decoder means what? Here 3 into 8 decoder means what? We have 3 inputs. We have 3 inputs, one enable line is there, and we have 8 output lines. Okay, like that we need to construct how much? 6 into 64 decoder we need to construct using 3 into 8, means input should be 6 and output should be 64. Okay, so how we will know how much 3 into 8 we require to construct this one? For that, one easy calculation is there. Just to you go through that. Whenever you will get like this, like that question, what you need to do? This is what, using 3 into 8, we have to construct 6 into 64. Okay, so you took this output. output value. 64 divided by this 8. 64, this 8 divided by equal to what? Equal to 8. Again you take this 8. 8 divided by this 8. Okay, 8, that is equal to 1. Like that you need to divide further till you will you will get till once it will divide completely. Till now you have to divide. Okay, so here it will finish. So 8 plus 1, that is equal to 9. Okay, so here you need 9 decoder to construct 6 into 64. Option C is the right answer. Like that you need to do calculation. Okay, now for what is the question? Which of the following circuit belongs to a class of combinational logic circuit? Okay, so combinational logic circuit. So in digital electronic circuit, there are two kind of logic circuit is there. First one is combinational logic circuit. Okay, logic circuit. And another one is sequential logic circuit. Okay, so combinational logic circuit means what? Combinational circuit is what? Conventional circuit is in which the present output is depend on only input, present input. Okay, and in combinational circuit they are not using any memory element to store. But in sequential circuit, sequential circuit in which the present output is depend on present input as well as future input also. Okay, if you see the combinational logic example, then combinational logic circuit is like adder, subtractor, multiplexer, encoder, decoder. These are the combinational logic circuit. And sequential circuit using memory element to store like flip-flop. So whenever you will find flip-flop circuit, that is nothing but sequential logic circuit. So like shift register and register and counter, all are the sequential circuit. Okay, so you have to remember these points. And here question asked about combinational logic circuit. So full adder and multiplexer is the combinational logic circuit. This register and counter is the sequential logic circuit. So here A and D means option B is the right answer. Okay, next. A 4-bit gray code for a decimal number 5 is. So we need to find gray code of this 5. Okay, so first what you need to do, you need to convert this thing in binary. What is the binary representation for this 5 is 0101. This is the binary representation of 5, you know, I think. Okay, so how you will convert this is this in the gray form. What you need to do, you need to take this value and you need to apply XOR operation. XOR operation means what? You know truth table of XOR A plus B. XOR like whenever 0 0 0 1 1 0 and 1 1 like that. So output is this is 0 and this is 1, this is 1 and this is 0. Okay, whenever inputs are same, that time it will low, and whenever inputs are different, that time it will high. Okay, now what is the process to convert this thing in a gray code? You have to take this MSB bit as it is, means 0 means 0. Now you have to take these two to XOR. So 0 and 1. 0 and 1 is what? 0 and 1 is 1. So this is what? This is 1. Again this 1 to this 0 you need to do XOR. So 1 and 0 is what? 1. Again you need to do this XOR. So 0 and 1 is what? This is again 1. So this is the gray conversion of this 5, number 5. Okay, suppose in question they will ask how you will convert this gray code in a binary value or a decimal value. So for that also you need to know same process is here. 0 1 1 1. Again you take this MSB as a 0, then you have to take XOR operation only, but output to input. 0 and 1. 0 1 XOR is what? It is 0 and 1. 0 and 1 is 1. Again this 1 to this 1. So this 1 1 1 is what? 1 1 is 0. again 0 and 1, 0 and 1 what 1. So see, binary number came 0 1 0 1. This is what, this is 5. So like that you need to convert gray to binary and binary to gray. So this is option A is the right answer. Okay, next. Determine the bandwidth required for an FM signal having frequency of 2 kHz and the maximum deviation is 10 kHz. So we have frequency is 2 kHz and del f yani ki means maximum deviation is what, 10 kHz. Okay, in FM means frequency deviation. If you calculate bandwidth equal to what, bandwidth equal to twice of del f plus fm. Okay, so this is what, this is 2 and del f is 10 plus this is 2, so 2 into 12, that is equal to 24 kilohertz is the answer. Option C is the right answer. Okay, now next. In the PCM system, if the quantization level are increased from 2 to 8, the bandwidth requirement will be. Okay, so how we are calculating number of levels, mean quantization level equal to what, level equal to 2 to the power n, like that we are calculating level. And if we talk about bandwidth in PCM, then it is what, NFS. Okay, n is what, number of level and number of bit, and fs is what, fs is sampling frequency. Okay, so here what they are saying, first L is what, L value is, quantization level is 2. Okay, if quantization level is 2, then what is the value of n? It should be 2 to the power 1 only, then it will become 2, level is 2, right? So here n is what, n equal to, here n equal to 1. Okay, now they are saying this 2 become 8. Okay, this 2 become 8, L become, level become 8. So in this case, what is the value of n? 2 to the power 3 means 8, right? So we know, we get the value of n is what, 3. Okay, so now bandwidth, so bandwidth equal to what, bandwidth equal to NFS. Okay, so what is the value of n? N is 3fs. So 3 times it is going to increase if level will increase from 2 to 8. If the quantization level are increased from 2 to 8, then bandwidth will become tripled. Okay, option C is the right answer. Okay, next we'll see. Okay, so a line has Z0 equal to 300 ohm. If ZL equal to 150 ohm, reflection coefficient is, we need to find reflection coefficient. So reflection coefficient is what, reflection coefficient is ZL minus Z0 divided by ZL plus Z0. So ZL is what, ZL is load impedance and Z0 is characteristic impedance. Okay, so we know the values, just put the values and get the answer. 150 minus 300 divided by 150 plus 300 equal to what, equal to, if you calculate this thing, you will get 0.333 minus 0.333. Option C is the right answer. Okay, so like this you have to calculate reflection coefficient. Now the antenna employed in television receiver. So in television, what kind of antenna we are using? Earlier we are using Yagi Uda antenna for TV and all. Okay, if you see the range, for this what Yagi Uda antenna, so it is 30 megahertz to 3 gigahertz. Sometimes they will ask about range of frequency also, so you remember this one.